Hello, I'm going to talk to you today about triggering using Insight. The task is microseismic processing software code. Triggering is selecting events from continuous waveform data. So we have a lot of information, a lot of waveforms. We want to select the interesting points that may lead to a located microseismic or acoustic emission event. I'm going to talk you through 4 of the main functions that Insight has for triggering. I'm going to start with the basic threshold limit, which looks at where a trace goes above a certain amplitude, and that becomes a trigger on that trace. I'm going to look at the auto-picking function, which is based off an LTA-STA algorithm. And then I'm going to show some new features that have been released in version 3.15. So the AIC, the Akaike Information Criteria, that's been updated, and the template matching filter. Template matching is completely new, so we can look at how that works and how we can use that to find more events, more acoustic emissions, more microseismic events in your datasets. So without further ado, I'm going to switch over to to some training data we have here. So this is already triggered. You can see here we have one singular event. So rather than a long waveform that may have been recorded over many days if you're in the reduced seismicity scale, or many gigabytes to terabytes on the acoustic emissions scale, we've got here just a small sample of the data where we have a P and an S wave that is in this case quite clear and easy to identify. So what we can look at initially here is the different triggering methods. So the first one just looks at the overall amplitude. I'm going to zoom in here on this instrument 5 and have a look at the traces. So when the I believe it's the absolute value of the trace goes above a certain limit, then a trigger will occur. So you end up with a trigger here. If you set a limit sort of down here, you can see this point trigger, or this point maybe. So that's a very simple approach. However, what we also need to bear in mind is that we need to see this over different instruments. And so normally we need to also give a measure of how close these triggers can be to each other for them to count as part of the same group, and also over how many instruments you need that trigger for again to select, as there's no point just having it on one. That would just be probably likely a noise spike. You also need to then select how much you need to select, the sort of length of the waveform window, and also a percentage of where you want the waveform trigger to be. So if it's in the middle, 50%, or front-loaded, 25%. And that's an overview of the threshold method. The auto-picking function, we have to make sure we've set up the processing settings correctly. So if you go into processing settings, go into auto-picking method, click the RMS amplitude, that's also what it's called, and that creates an auto-picking function using these parameters here. So it does the first one, which can be using the first peak in the auto-pick function or the maximum peak in the function. So that's pretty useful for deciding which one to do. And we have a back window length, a front window length, and again a threshold. And I'll show you how these properties go when you actually look at the waveform. So if I go again at this instrument 5, and then looking at one of the channels in detail, this Y channel looks quite interesting. What we can see here is we've got this auto-picking function down at the bottom, auto-picking function here. And we've got two. We've got one for the P and one for the S wave. And you can see here that the auto-picking function for the P wave wants to be picking here. So needs to make sure it's above this limit. And then for the S wave, however, It's picking way out here for some reason, so there's definitely some something not quite right with this auto-picking function. You can see how it works by cancelling the picks and then running them. You can see the P wave is working okay. The S wave works better once we've reapplied these. Because once it knows where the P wave is, it can start looking after that. So if I cancel them both again, we'll end up with a pretty confused looking thing. But once it's worked out where a P wave is, it can start looking at this S wave, and there we can see that this combines to create this S wave peak. So this is going to work pretty well on this data, this auto picking function. The other functions we've got is the AIC method. Check the settings of the AIC here. There's different type. AIC STA LTA, AIC modified is the new version. We've got some front windows, back windows, more parameters here than that we need to set to work out the AIC. We can close that, and again we can have a look at this AIC function and see how it tries. So again, we're looking at the fifth instrument, looking at the Y component, and we can see underneath here we've got another set of curves here, these characteristic functions and these auto-picking functions. And you can see how these functions are created using those windows, and they create and that can create if I clear the picks again, we have our characteristic function for P and for S, and our auto picking function. So we can try and pick again P and S. So we can see here our parameters are not set up too well. They're a bit sensitive. It's picking up something much earlier in the limit. And so maybe we'd look at trying to go back to our processing settings, our AIC method, maybe try upping this picking threshold. Go back to this data, clear some of these, and try again. It's still working quite early, probably because it's using this AIC method. So there's definitely some work needed to tune those parameters. So to look at how we tune those parameters, for my information, it's best to go back to the theory. So if we look at the theory of the LTA STA function, we can see that it's using a sum of all the events in a front window divided by the sum of all the events in the back window. And that creates this auto-picking function. So you can see here how it's a rough of the energy. This is, I believe, the amplitudes are scaled as well, so they're normalized. And then you can see that, you get this energy change. If you've got lots of things in the front window, but not very much in the back window, this function is going to go very high. However, if they're either mostly equal because you're within the noise, then the function is going to approach 1, and then after you can see. So that's a very simple approach. Whereas the AIC method, here's the equation for the simple version. It uses position in the waveform array, a log function of the variance within this amplitude. So from beginning to the end, plus some other constants, and times again by the log of the variance from everything from our current position plus 1 to the number of points, given the number of points in the waveform. So we can see how it's looking at the front. Again, it's looking at before and after points and trying to calculate a function from there. And that's the end of the sort of introduction and theory part of this this tutorial. So now I'm going to get through and do some real triggering and how it works in practice. So what we do in practice is you can end up without any data. So we haven't got anything to look at initially. So that no initial component, and there'll be no BIF files. I clicked on Manage BSFFs, none of these bit files, so we can delete this and reset this. And then we can look at which trigger method we want to apply here. So we can use, as I say, the amplitude threshold, the picking algorithm, which includes the AIC, and the match filter as well, I'm going to cover today. So if you click on the amplitude threshold, we have these very simple features. We have this waveform amplitude point, we have a window length, a number of trigger instruments, this trigger ratio, and this waveform length. It's normally a good place to start if you don't know too much about your data, if you don't know what size events, your frequency of events, then you've got a good measure of, you can get a good set of waveforms to come in. And you can always just keep lowering this number until something comes in, and then you can get a look at your data and try and work out, what we should be aiming for. So I've got all this set up with search directories, ESFs and BSFs directories, so they all need storing. So this is where the raw data is stored. This is where the data that we're going to be processing will be stored. So the triggered events will go into this folder, and this folder is a backup. So Insight likes to back up and uses this during this process to work through. File format is set here. We'll get this a MRF file format, and we're going to not do any processing this time because we're just looking at the waveforms, and we're going to do. There's a few methods. There's one that doesn't do any waveform storage. There's one that just stores the BSFs, and this is the full real-time operation, which is probably the default, and rightly so, because it imports the event straight into Insight for use. What you also want to check here before you start triggering is some of these other options. So reporting can be used if you need to know certain amounts. If you use a lot of data and you're just looking for rare events, this thing can set out some outputs to do automatically. There's also some audio settings. I'd recommend turning them off, particularly for this default, particularly for this sort of exploration phase, because they're just annoying. What we've also got, which are very useful, we've got alerts, so you can send emails and stuff when triggers come in. Again, it's not going to be very useful in this stage because we're going to hopefully be triggering a number of events quite quickly. So we're going to want, we don't want lots of emails or lots of beeps. We should be able to see it happening here. And the main way to see it happening is using this waveform watch feature. We'll show you little instances of the waveform so we can get a little analysis of what's coming in. And we've also got this show watch here, and this is much more of a text log. And this is great for debugging issues. It tells you why it's not working, what stage in the triggering process did it get to? Did it fail to read the files? Did it manage to read files but find nothing? And so it's very useful to have open. Once you've got everything ready, you can click to start leaching the data, and hopefully something interesting will occur. Yep, so it's found interesting, it's found new files, and would you like to stream this data? Yes, please. You can see here it's bringing in lots of data. There's not very clear signals here, and there's a lot of stuff that looks a bit rough, not very easy. I know this is going quite quickly, but it's quite a quick plot. You can see occasionally something comes through that's on a lot of traces, but most of the time it's only on a few and it looks quite rough. So I'm going to stop that there. We've got a sample of the early data here and see what sort of triggers we've got. So we can close these and have a look at these waveforms in more detail. And what you can see here is we're getting a lot of triggers every couple of seconds, some every millisecond apart. So what we've done here is we've set the triggering limit too low. We're getting too much information in. We've got 267 events in from 1719, so 20 past 5, to, still 20 past 5, 1722. So in 4 minutes, we've got 267 events. And this is, oh, by the way, this is large-scale data, so looking at a hydraulic fracture experiment. So that's very high. event rate. And what we'd expect here is that a lot of this is going to be quite noisy and not that useful. Yeah, we've got a reasonable bit of signal here coming through. Yeah, but this one looks very noisy. Yeah, and so we've got a large amount of data in total to look through. So having to look through this sort of thing is probably best to let the computer look through and seeing if it can find us only things that look sort of interesting, you know, that have really good signals on many traces, say this. And so you can actually look at this event here, double click in and see what the amplitude is. If you're holding if you've got your mouse cursor here, you can hover that over where you want to do. And then if you're looking at the bottom right, you can see there's an amplitude and time function. It appears here, down here, in this amplitude time. And that reads off the graph for you. So you can read off here that we're at amplitude 0.008. So that's quite sensitive. And so we can look at adapting our triggering technique to be a bit less sensitive and get us more interesting results. So to re-trigger, we delete this component, as otherwise it tries to import data into here, but there's already data, so it gets a bit confused. We also need to, again, delete these backup files, these BSFs and BIFs. So we've got that, and yeah, we saw that was sort of more like 0.05 maybe. We get some stuff that's a bit lower than that, some stuff that's a bit higher. Maybe to show you the difference, I'll go up a full to 0.01 and we can see what data we actually get with that. Again, open up this waveform watch to have a look at the quality of the data coming in, and this normal watch to show to see if there's any issues. For example, if you don't delete your component and don't reset the manage BSFs, it says, oh yeah, I found 10 files, but they're not new, so I'm not going to read them. So you need to make sure that you reset all those processes so that it can read them. So again, we get this, we found new files, we're going to continue with that. And we see here we're getting some data coming in. Again, this is obviously trying to plot things very quickly, so it's showing it, showing what we get at quite low resolution. But you can see in some of them there's events, some of them there's not. So again, if I close this, well, it's completely finished doing the whole of the dataset now, so it's got no new files found. I'll wait just a bit more because it's running, I believe it runs multi-processors, so there could be another processor still finishing up. But no, I think that's it. That's finished the triggering, as it says no new files found. So we can do that. We can click stop leeching, close this down, and we can see here we've got these events. And now we've got 112 events in in a slightly longer period. So less events, but more, but over a longer period. So you can see it's already working more sensitively. And we can see here, yeah, this one looks a bit noisy. Obviously, we can work with some filtering on some of this data. It looks quite, we've got a lot of things. I'll see if the filter's set up to work reasonably. It's not doing a lot at the moment. Need to set that up. But yeah, you can see that that one looks pretty good. That's good. We compare them in the waveform move out view, which is what I'm quite used to looking at. You can see there's some interesting spikes, interesting things going up and down. Some of this move out might not be big enough, so it might be that this is tube waves or issues like that. Identifying those can be very difficult, and sometimes you need a more advanced triggering method. So once you've got a bit of a review of what your data looks like, whether you've got clear PNSs, then you can look at other triggering techniques. So you can look at this auto-picking function. So here we've got a good looking event, and we can click on this trace here, and you can see here this is what our auto-picking function is currently doing. I believe it's set up to still look at the AIC. So if we switch that back to look at the RMS method, and go back to that trace and have a look, we can see here what our trace is doing. And you can see here we've got quite a few spikes here, but our limit for the autopicking function seems to be set pretty well, as that's going to find that P there, and then the S limit is low. Be careful of these different scales here. So the S is on a different scale here than the blue, just to help with the difference in amplitudes between the two. You can see here that S, yeah, that should pick up that pretty well. So when you do an auto pick on this data, it seems to work quite well. And that suggests that maybe it could be quite useful for the triggering. So if you go back to before you go back to the triggering, remember to clear the data that you've analyzed. You can delete the component, go back into triggering, delete the BSFs. And then we can switch to using the picking algorithm. From here you can set the picking out, the back window, the picking threshold, and the front window. And we can try using that on the data now. So again, open up your watches. You've got a text one and a visual one. And then we can start this data and see what we find this time. Again, we found the 100 files. It's reading through the files. It's going through. This is some measure of progress. It's a bit hit and miss as to how much is going on and stuff, but you can see that I think it just fills up these bars, and then when they're not being filled, there's no triggers, so we know what's going on. You can see here, yeah, no new events. So pretty happy that we're at the end here. This time we found 118 events, so a very similar set of events. And we can look at the waveforms here, and we can see we're getting very similar looking events. And these events might be able to p-pick some of these. A bit noisy, this data. Definitely would like to look at a filter for this and see what we can do. But initially we can see we've got some interesting signals that we can then work on and spend our time on. And we've not got too many, 118. Although this is for a sample of only 7 minutes, and if you've got a sort of longer data set, then this sort of event rate might be too high. You need to make sure that you can inspect your data and see what's happening, and just try to get the most interesting parts of the data possible. So the final processing technique. So what we could do here is use the AIC method works in a very similar way. So you just choose the picking algorithm and choose that. Or you can use the matched filter. And so the matched filter looks at using templates. So it looks at using events you already have and trying to calculate events that look similar to that using a cross-correlation method. So to find my set of template events, 118 seems like too many, and some of them didn't look great. So what I'm going to do is I'm going to calculate I'm going to look at just the highest events. So to do that, I'm going to use the auto pick, and that will locate the events, and then this will give me a measure of what are good quality events, what can be located. All the parameters for this dataset have been set up already, so the locator and everything. And I'll be covering these details in future tutorials. And so here we've got some events I've located, we've got some with residuals, we've got some. It's also calculated a lot of the waveform parameters, so signal to noise ratio, energy, S to P ratio. There's a lot of interesting parameters it's creating, RMS noise. So what we might do is look for sort of high signal to noise ratio events. We've got a lot of events with high signal to noise ratio, and maybe we can just use these, some of these top ones. So a quick look at them. Yeah, you can see here there's a very clear signal down the middle. There's a lot of noise there, but some really quite clear signals in these. So if what we could do is maybe select the top, top so many to keep as a sort of template event. Keep everything above, say, 3.5. We can throw this stuff away. It's not super useful yet. So we've got these events, and what you can do is you can use that as a template. So we go back to triggering. This time we don't need to delete our component, but we still need to delete these events. Reset that. We use the matched filter, which uses these templates. So what you can do here is you can select which events you'd like to use as a template. So I'm going to use all the events that I've got left in this component, or you can pick an individual event. And then it's going to look through this data again and seeing what looks numerically similar to this data. So we can start leeching this data and see what we find. System's found 100 new events, so that's good. It's going to start working. Again, you can show the watch, the text watch, or the waveform watch to see what's coming in. Again, this waveform watch is quite low quality, so as it's trying to quickly plot everything, it's not showing us everything. So we can see it's going through. It takes a bit longer, this technique, because it's comparing it's comparing the whole data set to each one of the traces, each one of the templates. So we know it's trying to find stuff. You can see here what we've got. The located events at the top are the ones I was using, and then it's adding so many more events at the bottom. You can see it finishes about here, doesn't it? So yeah, no new files found. No new files found. Yeah, so we can stop that leeching now and close that. And you can see that the data it's found down here. Yeah, I mean, that's got pretty good. That is a very high quality event that this was picked here, because it's trying to match these move outs and things. You have to be careful with the template matching and being generally too limiting. We're now down to 56 events. So we're getting a high quality, but a low number. And so it's always this trade-off between getting high quality and low number. And the higher quality is easier to process. The lower numbers mean that maybe you're missing certain characters of events. So different events from different places will have a different template, and different events from different sources will have different again, amplitudes in those templates. Different move outs as well. So again, different locations will affect the other triggering as well. If you make your triggering too selective, it can only be selecting certain very large events and in certain locations. So it's very good to try and explore these parameters with your data set and try and get that right balance between the number of events and the quality of events. I hope this triggering tips tutorial has been useful. I hope you found it entertaining or useful. So please let me know if you've got any comments. You can email me at support@itasca.co.uk and let us know what you think of this and if there's any other topics you'd like me to cover. I'm planning on going through a little bit of basic overview of an Insight microseismic processing flow. So looking at picking in detail next month. I look forward to seeing you then. Thank you, and goodbye.